This is AP Calculus test on limits through normal lines. First problem, determine which of the following statements are true about the graph of f of x to the right. Circle the correct multiple choice answer. And so you're given three scenarios, Roman numerals 1, 2, and 3. And first scenario is limit as x approaches 1 of f of x equals 2. Well, to have the limit as 2 is being approached, actually as 1 is being approached from the left and from the right, what are we honing in on? Well, we're honing in not on 2, but the value of 1 here. And so 1 is not correct, but Roman numeral choice 2 is correct because the value that we're approaching from the left and from the right side are both 1. And last choice, Roman numeral 3, is the limit as x approaches 1 of fx equals f of 1. Well, that would be a little test for continuity, third scenario, and that is not true. So our correct answer is answer choice B, Roman numeral 2 only. Next problem. To determine whether function h of x is differentiable at x equals 2, justify your answer using mathematical notation. Well, there are really two things I was looking for on this. One was to establish that the limit as x approaches, I'll just write it out here, limit as x approaches our critical number 2 from the left side of h of x equals the limit as x approaches 2 from the right side of h of x. So if we just work this out, on the left side we have this 2x squared, so we have 2 times 2 squared minus 4 times 2 plus 3 equals negative 3 times 2 plus 9. And just working this out, we have 8, 2 times 2 squared is 8, minus 4 times 2, 8 minus 8 plus 3 equals negative 6 plus 9. And we have 8 minus 8 cancel on the left side. So what we have left is 3 equals 3. And so we say limit as x approaches 2 of h of x equals 3. And since h of 2 equals limit as x approaches 2 of h of x h of x is continuous at x equals 2. And so that's one argument, and that's really half the problem, because now we need to go ahead and look at to see if the following exists. So this would be half credit for this all worked out on the left side, a demonstration of continuity. Now the next step for differentiability is to see if this occurs, if the limit as x approaches 2 on the left side of h, not h of x, but h prime of x, equals the limit as x approaches 2 from the right side of h prime of x. And what we're going to do is take the derivative of this left side. Well, the derivative of 2x squared is going to be 4x, and the derivative of minus 4x is going to be minus 4, and the derivative of 3 is 0. And on the right side, the derivative of negative 3x plus 9 is going to be negative 3. And now if we plug in the 2, we have 4 times 2 minus 4 equals negative 3. And so 4 times 2 is 8 minus 4 is 4 equals negative 3. Is that correct? No, it's not. Okay, since limit as x approaches 2 of h prime of x, since limit on the left side does not equal limit on the right side, we say this limit does not exist. Now, it's not equals does not exist, it just does not exist. Therefore, h of x is not differentiable right, it's not too legible at x equals 2. So I'm looking for both these arguments, the continuity argument here in blue on the left, and then the h prime of x equal each other from the left side and the right side. Next, 3. Differentiate each function, supply answers, write all answers without rational or negative exponents. Well, the first one is this g of x. To get g prime of x, we're going to have 3 times 7, which is 21, x squared minus 12, and the derivative of pi over 2 is 0. So this would be our answer for part A. Now for part C, we have these negative exponents here, and so I'm going to rewrite this as v of t equals 4t to the negative 2 power. And then what we have here, this next one is minus, we have 5/6, and that's going to be t to the power of, this is 2 and cube roots, it's going to be the power of negative 2/3. Next, for v prime of t, and we got to make sure that we make the transition correctly. Now haven't derived at this point up above what we've written already so far, but now it's going to be the derivative. So we take negative 2 times 4 t to the negative 3 power, and then we have negative 5/6, and then we're going to multiply this by negative 2/3, and we have t to the, well, negative 2/3 minus 1 is going to be negative 5/3. And so we have v prime of t is equal to negative 8 t to the negative 3, and this negative 5 times negative 2 is going to be plus 10/18, and we have this t to the negative 5/3. Well, I'm just going to bring it down t to the negative 5/3. Okay, the last step here, we get rid of our negative exponents, and we're not going to write with rational, we're going to write with radical. So we have negative 8 over t to the 3rd power, and this 10/18 simplifies to 5/9. So we're going to have plus 5/9, And this t to the negative 5/3 is going to be, that's going to be a third root. That's a 3 there. And we have t to the power of 5. So that's going to be part C worked out. Now, B, a lot of people who had problems with B. What you have is you have a product rule, a product of two functions. And so what we're going to do to organize this is make a box that we've done in class. And that box is going to be set up like this, where we have U and U prime, and below V, V prime. And so U is going to be 3x, U prime is going to be 3, V is going to be quantity 2x minus 1 to the power of 4, and V prime is going to be 4 times quantity 2x minus 1 to the power of 3 times the derivative of the inside, which is 2. I'll just put this 2 in parentheses. So to find the derivatives in the product rule, we're going to multiply, we're going to take 3 times this plus 3x times this. Right, in doing that, we have y prime is equal to, we have put 3x times 4 times 2. Well, 3 times 4 times 2, that'd be 24. So we have 24x, and then we have quantity 2x minus 1 to the third power, and now this circled in red is going to be plus 3. We have quantity 2x minus 1 to the fourth power. And that's as simple as we can make it. Now, D. I'm going to make an organization here. We're going to have we're going to use the quotient rule for this. And our low is going to be 3x plus 5. Our derivative of our low, which we'll call D low, is 3. Our high is going to be 2x minus 1. And our D high is going to be 2. And so now, writing below, we have S prime of t is equal to low, and low is 3x plus 5 times the derivative of the high, which is 2, minus high, which is 2x minus 1, times the derivative of the low, which is 3. And that's going to be all over low, which is 23x plus 5 squared. And just using our distributive property up top, we have 2 times 3x, which is 6x. We have 2 times 5, which is going to be plus 10. We have minus 3 times 2x, which is going to be minus 6x. And then we have 3 times 1, but we have a negative negative, so that's going to be plus 3. And we have all this over quantity 3x plus 5 squared. And we cancel out 6x minus 6x in the numerator. And what we have left is S prime of t is 10 plus 3, which is 13, over quantity 3 3x plus 5 squared. So that's part D. 4. Determine the value or values of x for which the function y equals x cubed plus 6x squared plus 9x minus 1 has a horizontal tangent line. Well, to do that, we're going to find the derivative, which is, we'll call y prime, is equal to 3x squared plus 2 times 6 will be 12x to the first power plus 9. And now we're going to define a horizontal tangent line. We set the first derivative equal to 0. And now we're going to solve this by factoring. So our common factor between all these terms here is going to be 3. So you have 3 times what equals 3x squared, well, that's x squared. 3 times what equals 12x, well, that'll be plus 4x. And 3 times what equals 9, that's going to be plus 3. And now, when we divide both sides of this equation by 3, we have 0 equals, now we're going to factor out the remainder of this. We're going to have x and x, and the factors of 3 are going to be 3 and 1, and if we multiply these back together, we have as our middle term 3x plus 1x, which equals 4x. So solving, we have x plus 3 is equal to 0, x plus 1 is equal to 0, so we have x equals negative 3 and x equals negative 1. These points are where, these x values are where we have horizontal tangent lines, and so that's our answer for 4. 5. Find each of the following limits. So we have this one here, which is a piecewise function. And to have a limit, we need the left side limit, which is this one here, I'm boxing in, is going to have to equal the right side limit. And in this case, this thing in the middle, where x4, when x equals 4, that's not relevant to a limit where x equals negative 4. So we're going to set the left side limit, which is x plus 4 over x squared, and actually be the limit as x approaches negative 4. I didn't write it right. As x approaches negative 4 of, we'll say from the left side, square root of 16 equals the limit as x approaches 4 from the right side of f of x, which is going to be simply this negative x over 16 minus 3/8. Okay. Now if we plug in 4 on this left side limit, we're going to get 4 minus 4, which is 0, and then x squared, which is 4 squared, 16, minus 16, so we're going to get 0 over 0. So what we have to do is try to factor the left side, so we have x plus 4 in the numerator. In the denominator, we factor x squared minus 16 into quantity x plus 4 times quantity x minus 4. And our right side limit, we can just plug in 4, negative 4, so we have negative, so we have negative 4 over 16 minus 3/8. I'm going to change this 3/8 into 16ths by making this 6/16. And so on the left side, we have x plus 4 over x plus 4 canceling each other. So we have 1. And what I'm going to do with this is I'm going to change that x to negative 4. So we have negative 4 minus 4. On the right side, we have negative, or negative is positive. So we're going to have 4/16 over minus 6/16. And what we have on the left side is negative 4 minus 4 is going to be negative 8. So we're going to have negative 1/8 on the left side. And on the right side, we're going to have 4 minus 6, which is going to be negative 2 over 16. And negative 2 over 16 equals negative 1/8. So our answer here is going to be negative 1/8. I think a lot of you got that right. Okay, the limit as x approaches infinity of 3x squared minus 2x plus 5 over 1 minus 4x squared. And for that, we take the ratio. We have x squared as the highest power in both numerator and denominator. So what we're going to get is our limit as x approaches infinity is going to be 3x squared over negative 4x squared. And your x squared over x squared cancel each other, and so what we're left with is 3 over negative 4, which is going to be negative 3/4. So when we, a little acronym thing, this would be a Betsy situation. Next, C. What we're going to do is plug in 2, because that's the first step. So we're going to have cube root of 6 times 2 minus 4. What that's going to be is 12 minus 4. We're going to have the cube root of 8, which equals 2. So 2 is our correct answer for part C. D, the limit as x approaches 3 of pi cubed. This is kind of tricky for a lot of people. What you have is a constant function, and what you have is the horizontal line of pi cubed. So it's going to be y equals pi cubed, pi to the third power. And so as x approaches 3, okay, here's x equals 3. The limit from the left side, it's going to be pi cubed. The limit from the right side, the limit from the left side is also going to be pi cubed. So our answer is going to be pi cubed. And the lesson we learned is wherever you don't have a variable in here, in a constant, there's no thing to plug in x for, so that's going to be your correct answer right there. The last one, this says limit as h approaches 0 of 5 of quantity x plus h cubed minus x quantity x plus h minus 5x cubed plus x. And this is a definition of derivative situation here. And what you have is a situation where f prime of x is equal to the limit as h, as I said h. I wrote down x as h approaches 0.
Good morning. Just a reminder, we are having a BOC meeting in about 5 minutes in the media center. Thank you.
Of x plus h minus f of x all over h. And what we need to know is that what that function f of x is, because if we know what that is, it'll make it easier. Other than that, we'd have to expand this thing out and cancel. Well, all we have minus f of x. So for this to be minus f of x, what does f of x have to equal? Well, f of x is going to be, since we have minus f of x, we have 5x cubed, and it wouldn't be plus x because this is plus x, so we're going to have minus. If we look at the left side here, 5 quantity x plus h cubed minus quantity x plus h, this is going to be our f of x right here. So therefore, f prime of x, which is our limit as h approaches 0 of all this, is going to be 15 x squared minus 1. So that's our correct answer for E. 6. Find the average rate of change of f of x equals negative 3x squared plus 5 over the interval from negative 1 to 3. What we have here is we're going to let negative 1 be A and 3 be B. So our average rate of change is going to be f of B minus f of A over B minus A. So we'll just find f of 3, which is B. So we have negative 3 times 3 squared plus 5. And that's going to be 3 squared is 9 times negative 3. That's going to be negative 27 plus 5 is equal to negative 22. And then f of A, which is f of negative 1, is going to be negative 3 times negative 1 squared plus 5, which is going to be, this negative 1 squared is 1, so we have negative 3 plus 5 equals 2. So our A-rock is equal to f of B, which is negative 22, minus f of A, which is 2, over B, which is 3, minus negative 1, which simplifies to negative 24 over 4, which is negative 6. So that's our correct answer. And I look for units. I don't see any units here, so it's just going to be the number negative 6. 7. Let g of x equals 1 over x squared plus 2. Write an equation line tangent to the graph of g at x equals negative 1. Well, to find the equation of line, we need a point, and for this point, we know that our x-coordinate is negative 1, and we also need a slope. So we need to find a y-coordinate for the point, and then we need to find the slope. Well, to find our x-coordinate, when we find our y-coordinate, we're going to plug in negative 1 to this function here. So we have 1 over negative 1 squared plus 2. And what that's going to be is this denominator is going to be 1. So we have 1 over 1 plus 2, which is 3. So our y-coordinate of our point is simply 3. Now to find our slope, we're going to take the first derivative of this g of x, and we're going to rewrite g of x as x to the negative 2 power plus 2. This 1 over x squared is x to the negative 2 power. So next, g prime of x is equal to negative 2 x to the negative 3 power, and the derivative of 2 is 0. So g prime of x is equal to negative 2 over x to the third power. And now to find the slope at x equals negative 1, if we put g prime at negative 1, we get negative 2 over, we have negative 1 to the third power. What that's going to be is we're going to have negative 2 over negative 1, because negative 1 cubed is going to be negative 1. So our answer for that is 2, and that's going to be, we call m sub t. So m sub t, which is the slope or tangent line, is 2. So now for our equation, we're going to have y minus y1, and that's going to be minus 3 is equal to m times x minus negative 1, which is going to be x plus 1. So this is going to be our answer right here in black. Next problem, 8. Find the instantaneous rate of change of y equals 1/2 the fourth root of x at x equals 81. Well, I'm going to rewrite this as y equals 1/2. We're going to have x to the power of 1/4. So y prime is equal to 1/4 times 1/2 x to the, well, 1/4 minus 1, so it's going to be x to the negative 3/4. And so y prime is going to be equal to 1 over 8. This 2 times 4 is 8 in the denominator. And we're going to have the fourth root of x to the third power. And now if we take y prime, we want to find it for 81. I'll call it y prime of 81 is equal to 1 over 8 times the fourth root of 81 cubed. And really, according to the principles of free response, once you've come to this point, you have really found your answer. If you go on beyond that to simplify, the way to do this without a calculator is not to take 81 cubed first, because that's a huge calculation, and then to know what the fourth root of that'll be tough. What you look for is the fourth root of 81 first, so what times what times what times what, that what being the same thing, equals 81. What you're going to have is the fourth root of 81 is 3. And so you're going to have the fourth root of 81, which is 3. You have 3 cubed. So you have 1 over 8 times 27, which is 216. I'm going to go back and make sure correct-wise. If you ended up getting it just this far as what I'm boxing in, I'm going to call that a correct answer. So I'll double-check the grading of that. Next. 9. Find the equation of line tangent to the graph of h of x equals x cubed minus 4x squared at the point where h prime of x equals 3. Well, let's go ahead and find h prime of x. H prime of x equals 3x squared minus 2 times 4, which is 8x. And we're going to find where h prime of x equals 3. So we replace h prime of x with 3. We have 3 equals 3x squared minus 8x. And then to solve by factoring, you subtract 3 for both sides of this equation. We have 0 equals 3x squared minus 8x minus 3. In factoring, we have 3x and x. And then we're looking for the factors of -3, which will make all this thing add up. So I believe if we take -3 over here and put +1 on the left factor, we're going to end up with -9x. So we're going to have 3x plus 1 equals 0, and then also x minus 3 is equal to 0. And if we solve for x, we're going to have x equals -1/3, and then x equals 3. And it says find the equation of the line. Well, what it is, you have a choice here. Okay, so I'm going to use the one that will be easier to work with. Sometimes you'll see the equations, in which case you have to find the equation of both these lines. But we know our slope, because we were already given that at the beginning. Our slope is going to be m sub t is equal to 3. We know that. But our point, that's what we need to find. And we have, our point is going to be x equals 3. And then if we plug in, we'll say h of 3, it's equal to 3 cubed minus 4 times 3 squared. We're going to get 27 minus 36, right, 27, and then this is going to be 9 minus 36. So it's going to be -9. So -9 is our y-coordinate. So our equation of this line tangent is going to be y minus -9, so it's going to be y plus 9, is equal to our slope, which is 3 times 20x minus 3. So that's our answer. Yeah, we could have used 1/3 as an x-coordinate also, but the arithmetic is going to be easier using this input of 3. Next problem, 10. A city in Oklahoma has experienced varying temperature changes within the month of March. Temperature P of T in degrees Fahrenheit on various days during the month of March are given in the table below. And so what we have to look at when you have a table like this, you have to look at input, output. And so our input in time is usually our independent quantity. So we'll call this our input value here, and then our output is this lower row. And so you're trying to estimate the value of p prime of 4. Show the computations that lead to your answer. So we have p, but what's p prime? Okay, well, we don't have p prime, but we have p. And so what we have is what this is. This is an A-rock situation. And that's going to be f of b minus f of a over b minus a. In this case, for t equals 4, we're between t equals 3 and t equals 6. So we're going to let 6 equal b and 3 equal a. So what we have here is f of b minus f of a, and that's going to be f of b is 75 minus f of a, which is 72, over b minus a, which is 6 minus 3. And what we have here is we have 3 over 3, which equals 1. And it says use correct units. Well, we have degrees Fahrenheit would be our units, and then time is our days. So we would have 1 degree Fahrenheit per day. So that would be the answer given in correct units. And then B, interpret the meaning of your answer in part A. Well, what this means is the interpretation would be the rate of temperature. I'm just going to put a temperature TMP change is 1 degree Fahrenheit per day. And now part C. Part C, I can see it's like, must there be a time when P of t equals 81? And I saw a lot of people answer yes to this question. And if you just look at this, you see, well, here's the temperature at day 11 is 79, and temperature at day 16 is 82. And so obviously 81 had to be in between there. So it's articulating this properly. And you can do a long articulation or a short one I'm going to show you now. What we have is 81. 81 is greater than 79, which is P of 11, right? But it's less than P of 16, day 16. So this shows 81 squarely in between day 11 and the temperature at day 11 and day 16. Therefore, according to intermediate value theorem, there must be and what is the language? Must there be a time? So there must be a time when P of t equals 81. And you could have also used, besides that one, there's another place you could say that between day 16 and day 18. So you could write this also and make the same argument, is that 81 is greater than P of 18, but less than P of 16, and then dot, 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 okay? Same. So it's making the case. Now, you could have made a more verbal explanation, but this inequality way is the most efficient way of writing this out. So actually, they're going to be at least 2 times when P of t equals 81. So justification, proper articulation, very important here. 11, write the equation of line normal to the graph of y equals 3 over x squared at x equals -1. Well, for this, what we have is we need a point, and our point is going to be the x-coordinate -1, and the y-coordinate we don't know yet. So we're just going to go ahead and work that out first. We're going to say y of -1 is equal to 3 over -1 squared, which equals 3 over 1, which is 3. So that's going to be our point. And next, to find our slope. And our slope, we're looking not for the slope of the tangent line, but the slope of the normal line. So we're going to find what that is. But the first step is finding what y prime is. And y, first of all, is going to be equal to 3x to the -2 power. And y prime is equal to -2 times 3, which is -6. We have x to the -3 power, which is going to be -6 over x cubed. Now y prime of negative 1 is going to be equal to negative 6 over negative 1 cubed, which is going to be negative 6 over negative 1, which equals 6. And that's going to be equal to m sub t, or the slope of the tangent line. And the slope of the normal line, m sub n, is going to be negative 1/6. So negative 1/6 we put up here. And so now for the equation of our normal line, it's going to be y minus y1 equals negative 1/6 times x minus negative 1, which is going to be x plus 1. So that's problem 11. Problem 12, determine the value of k, or values of k that make the following function continuous. Use correct math notation. The correct math notation has to be this. The limit as x approaches 1 from the left side of f of x equals the limit as x approaches 1 from the right side of f of x. So what we have is we're going to have 1 minus k equals 1 squared minus 4 times 1 plus k. That was a loud announcement. So on the left side we have 1 minus k. On the right side we have 1 squared minus 4 times 1 minus 4 plus k. So we have 1 minus k equals negative 3 plus k. So if we add k to both sides of this equation and add 3 to both sides of this equation, we're going to have cancellation here and here. So what we have is 4 equals 2k. So k is equal to 2. So that's our answer for problem 12. Problem 13, our last one, we have this integral from 0 to 10 of 1/2 x dx. What that's going to be if we take this function here, 1/2 x, and we go from x equals 0 to 10, but with 1/2 we have a rise over run of 1 over 2. So we're going to go up 1 over 2. And so to get over 10, we're going to have to go up 5. So what we're going to look like is this. We have the area of this triangle, which has a base length of 10 and a height of 5. So 5 times 10 divided by 2 is going to be 25. Another thing you can do is you could rewrite this thing as you can take this 1/2 out front of 0 to 10 x dx, and you would have the same thing. You would get 10 times you would get 50, because you get 5 times 10 anyway, divided by 2. But 25 is our correct answer. Anyway, these are all the problems. Good luck examining. Learn from your mistakes. And you actually know a lot to do what you did here. Thanks for viewing.